Hello class, welcome to Pre-Algebra Lesson 3.6, which is all about rational numbers. By the end of this lesson, you should be able to identify terminating and repeating decimals and use long division to convert rational numbers to decimals. So the first thing I'm going to talk about before I move on to the example is let's talk about the word terminating. Terminating means that something comes to an end. So an example of a terminating decimal would be 0.25. A repeating decimal is where numbers repeat. It's in its name. So if we have a decimal that looks like this is a pretty common repeating decimal where we have 0.3333 and that 3 continues on, fills up your entire calculator screen, but it goes on forever and ever. Sometimes we write it in a faster way using something called bar notation, where you put a line over the number that repeats. Sometimes you have multiple numbers that repeat, and so this would be, if I have 0.121212 and that goes on forever and ever, it becomes 0.12 with a bar over the 1, 2. Okay? You can also have a number where it's maybe like 0.306 and the 6 is repeating but nothing else. That is written in bar notation like this, where the bar only goes over the 6 because that's the only number that repeats. Okay? So those are our repeating decimals, and then terminating is when decimals come to an end. So 0.25, 0.3, 0.589, all of those come to an end. Those are terminating decimals. Okay. So let's do a little bit of review with some long division, because for some of you it's maybe been a while. So if I ask you to solve 414 divided by 18, let's talk about what that looks like in long division. So I'm going to write 414, so the first number goes inside like the little house thing, and then the second number goes outside. And what you're looking at is does 18 go into this very first number? Does 18 go into the number 4? It does not, because 18 is bigger than 4. So I'm going to just put a 0 there. And I'm going to move on and say, does 18 go into 41? And 18 times 1 is 18. Okay, so that could go into 41. 18 times 2 is 36, so that could go into 41. 18 times 3 is 54, so now I've hit the number that's bigger than the number inside, so I can't do 18 times 3. So I say 18 times 2, and that is 36. So now I write the 36 below the 41, and I subtract. And 41 minus 36 is 5. Now you can see I still have that 4 up top, so I bring it down. Now I have 54. And luckily I had just checked and know that 18 times 3 is 54. So then I write 54. And 54 minus 54 is 0, so there isn't a remainder. So my answer would just be 23. Because we never have to write a number with a 0 in front of it unless there's a decimal. So our answer is just 23. Next, I want you to solve this one on your own. 161 divided by 7. Good luck. All right, hopefully if you solve this correctly, you ended up at the number 23 again. Okay, because 7 can go into 16 2 times. And 16 minus 14 is 2. Carry down the 1. 7 goes into 21 3 times. So our answer is 23. All right, now let's practice writing fractions as decimals. So if I want to write 1 over 40 as a decimal, that's another way of writing this. So on the last slide, I wrote it out like that. On this slide, it's written as a fraction. It's the same thing. So I'm going to put the 1 inside the little house, and I'm going to put 40 outside. Since the number outside the little house is bigger I need to add a decimal place and a 0. And if I'm looking at that, because 40 can't go into 1, that's why I had to add that decimal place. 40 still can't go into 10, so since there's a decimal, now I have to put a 0 up top. If I add another 0, now can 40 go into 100? It can. It can go in 2 times, which is 80. So 100 minus 80 is 20. And I'm going to add another 0 and bring it down and say, can 40 go into 200? And it can. It can go in 5 times. So 40 times 5 is 200. 200 minus 200 is 0. So I know that my answer is going to be 0.025. All right. Now for these problems, I'm going to make sure, or I'm going to require that in order to get credit, you have to show your work. You can use a calculator to get some of the math facts down, but you have to show each step just like I did on the board. So everything in blue, you would have to have on your paper to get full credit, okay? All right, now practice with this one. Write -5/6 as a decimal. Determine if the decimal is a terminating decimal. I skipped that part on example 2, so sorry. I'm going to go back for a second. 0.025, none of that repeats. It came to an end, so this is a terminating decimal. Okay? Now you get to write -5/6 as a decimal and then determine if it is a terminating decimal. Good luck. Okay, for this problem, hopefully your work looks something like mine, where you added a few zeros. You saw that the 3 was repeating, so your answer would be 0.83 with a little bar over the top of the 3 to represent the repeating. And it was a -5/6, so that means it's a -0.83 repeating as a decimal, okay? And since it's repeating, this is not a terminating decimal. Because if it's repeating, that means it's going on forever and ever and doesn't end. All right, now let's practice going the other way. Let's practice writing repeating decimals as fractions. So if I want to write 0.5 repeating as a fraction in simplest form, I'm going to practice something a little different first. What if I take away that bar notation? And I say, let's write 0.5 as a normal fraction. So the way that works is you write 5 up top, you put a 1 on bottom, and then however many spaces you have after the decimal, that's how many zeros you do. So this would be 5/10. Or if you simplify it, it becomes 1/2. Okay, but if we're talking about a fraction that is repeating, it's a little different because it's not just 0.5, it's 0.555, and that goes on forever and ever. So instead, we put the 5 on top, and instead of putting a 10 on the bottom, we put a 9. And the way you know how many 9s to put is how many numbers are repeating. So if we had 0.232323, that would be 23/99 because there are 2 numbers that are repeating. Okay, so that's how you convert a repeating decimal to a fraction in simplest form. So when it's a repeating decimal, you put it over 9 or 99 or 999. Depends on how many numbers are repeating. Okay, now it's your turn. I want you to write 0.7 repeating as a fraction in simplest form. Good luck. Hopefully you said it's only the 7 repeating, so you put 7 over a single 9. So 7/9 is your answer. If you have questions about that, please be sure to ask for some help. Okay, now let's look at example 4, writing a repeating decimal as a mixed number. So let's refresh our minds. What does a mixed number mean? That's when you have a whole number and a fraction. So in this case, our whole number is 2, and our fraction, I have 1 and 8 on top because 2.18, repeating, the numbers under the bar notation go on the top of your fraction. And since I have 2 numbers repeating, that means that it gets put over 2 nines. So 2 and 18 99ths. And I want to simplify that. So that 2 is going to stay just like it is. But if I look at 18 and 99, I know that 18 at least is divisible by 3. And so if I do 18 divided by 3, I'm left with 6. And if I do 99 divided by 3, I get 33. Okay, so I saw that both of the numbers were divisible by 3, so that's what I did. But I'm still not done because I see both of these numbers are also divisible by 3. So 6 divided by 3 is going to give me a 2. 33 divided by 3 gives me 11. Now, there aren't any numbers that 2 and 11 are both divisible by. So our final answer is going to be 2 and 2/11. Okay, this is the last question for you. Write 1.42 repeating as a mixed number in simplest form. Good luck. Okay, hopefully you first set it up as 1 and 42 over 99. And then if you simplify that fraction, you saw both of those numbers are divisible by 3. So you have 1 and 14/33. If you have questions about this example or anything else from this video, please be sure to reach out for some help. I am happy to help you. I hope you have a great day.